Okay, question 17. The height h in meters of a batted ball has a function of time t seconds since the ball was hit and can be modeled by the function h equals minus 2.1 t minus 2.4 square plus 13. What is the maximum height of the ball? Well, if we were to graph this, it'd be upside down from this minus. We would know that the vertex would be up 13, it'd be 2.4 in the positive direction, and be up 13. So essentially, what we'd have is some kind of parabola like that. The ball would be going at, the ball would reach its maximum height at 13, and when would it happen? At 2.4 seconds. Okay, so A, max height is 13. Of course, this is because this is in vertex mode, is in vertex form. B, what is the height when it was hit to the nearest tenth of a, what was its height when it was hit? Okay, so at, what does that mean? When it was hit, what was the height? So when t equals 0, that's at the beginning of time. So I didn't graph this perfectly, but where does it intersect? The y-axis, or in this case, the h-axis. So the simple solution is pretty straightforward. H equals minus 2.1, t equals 0, minus 2.4 square plus 13. Well, that's 2.4 square. So that becomes 5.76. What happened to the negative? It got squared, so it's positive. Minus 2.1 plus 13. Whoops, let's write that more nicely. What comes next? H equals negative 12.1 plus 13. H equals, well, that we can do, 0.9. 13 minus 12.1 is 0.9. So B would be the height when the ball is hit is 0.9 meters, which makes sense as well. C, how many seconds after it was hit did the ball hit the ground to the nearest second? So C. So we have something like, it goes up, comes down, and it happens, that's at 2.4 seconds. That's at 0.9. And the height here is 13. That's what we know so far. We want to know what that value is. So what do we know about this value? Well, we know that the y value is 0. What is, sorry, the h value, height, y value. They correspond to each other. The height is 0. What is the t value? So what do? We get our formula. Where was it? It was this right here. Or we can get it from the question. H equals minus 2.1 t minus 2.4 square plus 13. And we solve for when h is 0. So what do? The first step is we move this 13 to the other side of our equal sign. So we end up getting minus 13 equals minus 2.1. t minus 2.4 square. Our next step, divide both sides by negative 2.1. Negative 2.1. Why? So we're trying to isolate for this t. So what do we end up getting? That crosses out. Two. 6.2, and this becomes positive, of course, equals t minus 2.4 square. The next step is, how do we get rid of this square? Well, we have to take the square root of both sides. Actually, let's do that in red. Take the square root of this side and the square root of that side. We end up getting, well, this side is easy. It just becomes t minus 2.4 because we take the square root of it. The other one we have to do, so we get 2.5 on this side. Now, this is positive or negative, right? Because negative 2.5 squared would give me approximately 6.2, and positive 2.5 squared would give me 6.2. The next step is to bring this over to that side. Or let's first actually rewrite this term in two terms, right? So we have two possible answers. We have 2.5 equals t minus 2.4, and we have negative 2.5 equals t minus 2.4. So let's solve both of them independently. So what's our first step on this side? Isolate for t by adding 2.4 to both sides. 2.5 plus 2.4 equals t. T equals, and I can do this on my own, 4.9 seconds. Looking at this side, we know that we want to bring 2.4 over to this side. We end up getting t equals minus 2.5 plus 2.4. So we end up getting negative 0.1 equals t. Now what's the problem here? The problem is t is negative. So this answer cannot be the right answer that we're looking for, which means the ball will hit the ground at 4.9 seconds. Okay, finally, D. What was the height of the ball? What was H when t equals 1 second? Well, let's see what we know. We know that that's 0.9. We know that it goes up. We know that that's 4.90. We know that that's, the vertex is 2.413. We want to find it after 1 second. We want to know what h is after 1 second. So let's try. We substitute t equals 1. H equals minus 2.1. 1 minus 2.4 square plus 13. We end up getting, we're going to solve this first. So 1 minus 2.4 is negative 1.4. If we square it, oh yeah, plus 13 minus 2.1 times minus, whoops, let's write it in the same number. Okay, the next step is to square 1.4. So we end up getting 1.96. That comes from here. plus 13, but we have to multiply it by negative 2.1 h. Our next step, h equals 4.116, don't forget this negative, plus 13. H equals 8.9. So at 1 second, that's 1 second, this would be about 4.9, or sorry, 8.9 meters. But anyway, we can just state that. After 1 second, the ball has a height of 8.9 meters. Okay, that's it for question 17.